So today's whole lesson is going to be multiplying and simplifying radical expressions that are, could be square roots, cube roots, fourth roots, fifth roots, things along those natures. So for the warm-up, they just want us to find each missing factor. So what is being multiplied by 5 squared to get me 150? And so you can actually solve it for the missing blank if you want through division, but dividing by 25, we should get 6 for that one. See if you guys can fill out the rest of them. Some of them are being cubed or squared, so take that into account whenever you're filling in the missing blank. All right, who can tell me what they got for number 2? Sam? 3. 3 cubed is 27, and 27 times 2 would get us 54. How about for number 3? Abby? 3. Also 3. How about number 4? Jade?
X squared.
X squared. Good. X squared, squared, power to a power. We multiply those to get x to the 4th, and then you would add that 1 to get x to the 5th. Very good. How about 5? Garrett? AB. A cubed would get us A cubed. B cubed times B would get us B to the 4th. And how about for 6? Steven, what'd you get?
I didn't get that.
You didn't get that far. Maddie, what'd you get? You didn't get that one? Lexi.
I got to 5, 8, and
You got to the 5AB, and then you weren't sure? So it definitely is going to be 5, because 5 squared is 25, and 25 times 3 is 75. Now, we need it to get to be a to the 7th. So one thing you can do is you could just like divide by a to actually figure out what we need to get to. So this would be a to the 6th, because we'd subtract those, and b to the 8th. Now, we're squaring that quantity, so remember, to square you would multiply. So to get 6 from multiplying by 2, this has to be a cubed. And b to the 8th, this must be b to the 4th. So that 3 times 2 gets me 6, and 4 times 2 gets me 8. So when you're multiplying radical expressions, the numbers do need to be raised to the same root, okay? So it has to be 2 square roots, 2 cube roots, 2 fourth roots. You cannot multiply things that have different indexes. So if you had the square root of 2 times the cube root of 3, you cannot multiply those. They have to have the matching index, okay? And if they are real numbers, then when you multiply them, you can just multiply and put them under one root with that same constant index. And then, of course, simplify further if possible. So for number 1, multiply and simplify if possible. We would multiply these straight across, and we'll get the square root of 36. And then we can take the square root of 36, which is 6. Again, our book is going to have the principal root, which is just the positive, and that's because the square roots are already drawn in. But we know that if we were finding the square root of 36, it actually technically is positive or negative. But again, in the answer key online, it's not going to have that plus or minus. The next one, we do have 2 cube roots, so we can multiply those together and get the cube root of negative 64. What is the cube root of negative 64? Caleb? Negative 4. A couple of you on your partner challenge Friday were putting plus or minuses here. Make sure if it's an odd root, a third, a fifth, a seventh, a ninth, it's only going to have a positive or a negative, not both. The next one, we have square roots. We'll multiply those together. And then what is the square root of negative 64? Austin? No real roots. Now, technically, if we wanted to, we could have an imaginary answer. What would the imaginary answer be? Sam? 8i. Okay, but for this, we're going to be looking at real numbers only, so it'll have no real roots. Not possible because of that negative. I don't know why I gave you so much space to do these. Again, make sure that the indexes match. For some reason, I don't know if it's on the homework or somewhere, that they will be different, so make sure you don't multiply them if you're not allowed to. We'll get the cube root of negative 27, and then we'll take the cube root of negative 27, which would be? Garrett? Negative 3. For number 5, same thing, we have matching indexes, we multiply those and we get the fourth root of negative 16. What would the fourth root of negative 16 be? Sam? No real roots. And you can't take an even root of a negative number. Now for the next one, you can multiply 16 and 9 together. However, each of those are perfect squares by themselves. So if you want to make your calculations a little bit smaller, you can root them first and then multiply them together. If you don't like that, you can just multiply them and then root it to get our 12. All right, now on the back we're going to add in algebra variables and not just have numbers. And something you do want to keep in mind are, we do have some square roots. We also have cube roots. So for square roots, we always break the number down into a perfect square, 1, 4, 9, 16, 25, and so on. When you have perfect cubes, you need to think of your perfect cubes list. Which would be our 1, 8, 27, 64, and so on. Those are the numbers you want to think of when you're breaking it down into the two numbers. And you have to kind of keep yourself in that mindset whenever you're looking at the different types of roots. So we're going to see some that have just like one variable, and then you can see down here we are going to have ones where we have to multiply and then simplify them. So square roots, normal, breaking our numbers into things that multiply to 50, and our one is a perfect square, so 25 and 2. Now for the x to the 5th, remember when you're taking the root of a variable raised to a power, you are going to be dividing. So some students will do 5 divided by 2 in their head. Other students prefer to break this up into the largest even number and then have that one left over. So for x to the 5th, I might do the square root of x to the 4th times the square root of x to the 1st. 4 plus 1 is 5. And then that way, we know we can take the square root of any even exponent. So we'll take the square root of 25, which is 5. We'll take the square root of x to the 4th, which is x squared, which it was even to an even. Oh, it says assume all the variables are positive, so you don't have to worry about absolute values. And then the other things, we can't take the square root of 2 and we can't take the square root of x. So those will just kind of go back together under one root. So these stay outside, 5x squared, and 2x stays inside. Now number 8, we switch gears, we're in perfect cubes. So what would I break 54 down into, numerically wise? To be a perfect cube. Abby?
27 and 2.
Good, 27 and 2. Again, you don't have to write all this out. If you can do it in your head, you're welcome to. Just, I like to write it all out so that we can see what's actually reducing and what's staying. Now, whenever I break the n to the 8th, again, I want to pick the largest number that's actually divisible by 3. So like 8's not divisible by 3, 7's not divisible by 3, 6 is divisible by 3. So I break this into the cube root of n to the 6th power, and then I just subtract those. 8 minus 6 gets me n to the 2nd that I'm left with. So that I double check, 6 plus 2 gets me back to my 8. And then we'll take the cube root of anything we can. So the cube root of 27 is 3, positive 3. The cube root of n to the 6th, remember we divide those and we will get n squared. And then the other two things can't be simplified. They go back together under one root. So we'll have 3n squared times the cube root of 2n squared. Just be really careful that your exponent on the variable does not look like the root of your root. So just be careful. Sometimes those can run together. See if you guys can find numbers 9 and 10, and then we'll add in some more variables below. 5x minus root 2 is correct. We should have broken that down into 25 and 2. And you can actually just take the square root of x to the 4th, which is x squared. All right, now this is the one I was kind of insinuating. This 18 is not reducible. It is divisible by 1, but that doesn't do anything. It's not divisible by 8, 27, and so on. So the number would stay. Now the x's you can reduce. So this would be cube root of 18 stays. Now again, you want to take the largest number that's closest to 4, that would be divisible by 3, which would be 3. So if the cube root of x cubed, and then that would leave me with the cube root of x to the first. 3 plus 1 gets me back to 4. And then the only thing you can cube root is this, which gets me x. Now, quite a few of you, when I was walking around, you didn't write the index in your answer. So if you have x square root 18x, it's technically not right, because it's a cube root. So just make sure that you do copy down the index that was given to you in the problem. Just the cube root. Okay. Down here they ask us to multiply and simplify. So again, you can take the square root or cube root if you have a perfect cube like right away, but usually you won't, and you'll want to multiply those together. So remember, our exponent rules are that if we are multiplying like x to the a times x to the b, we would add those to get our new exponent, the product rule. So the same thing works with our radicals here. We'll get the cube root of 125. That's x to the first times x to the fourth, which will be x to the fifth. And y to the eighth times y to the third would be y to the 11th. Now 125 is a perfect cube, that's just 5. So you can just take that. Now in regards to the exponents, again, we have to break them down. So, and some of you can realize that 3 of them will get taken away, you're left with 2 left over. You don't have to show that. Garrett?
How would it be x?
We had x to the first and x to the fourth. So I added that 1 in, the imaginary 1, and then I add those together. Anytime there's not an exponent written, there's an imaginary 1. So you kind of need to think about that to add it. All right, so I'll break the x to the fifth into x to the third times x to the second, which gets me back to my fifth. And then for my y to the 11th, again, you're just kind of starting. 11 is not divisible by 3. 10 is not. 9 is. So I would have y to the 9th, and then I'd be left with y to the second. 9 plus 2 is getting me back to 11. And then we take our perfect cubes. This will get me just an x. And this one will get me a y cubed. Those are now outside terms. Everything else goes back under my radical. So I'll have 5x y cubed. And then make sure you have that index, the third root of x squared y squared. Example 12, we have outside numbers and we have inside numbers. So remember, they act as if they're like terms. So we are going to multiply the outside numbers together to get 6. These are both square roots, so we can multiply everything together. And we'll get 147. We'll multiply our 7 and 21. And then again, we're going to add the exponents. So this will be x to the 6th and y to the 7th. And then we have to see if 147 can be broken down using any perfect squares, because this is an index of a 2. What numbers divide in there? Caleb?
49.
Good, 49 and 3. And then we'll also have the square root of x to the 6th and then square root of y squared. I don't have to change these because those are both divisible by 2. So you don't have to break those up. You can just kind of leave them. So we'll take the square root of 49, which is 7. We do multiply our two outside numbers together, 4 times 7 to get me 40, or 6 times 7 to get me 42. Also can take the square root of x to the 6th, which will be x cubed, and the square root of y squared, which would be y. And this is one of those cases where we normally would put absolute value bars around here, but since it says assume they're positive, we don't have to. So we'll have 42x cubed y times the square root of 3. Uh-oh. No, that's right. Last one, same thing. Now these are perfect cubes. So again, whenever we're reducing these, remember, think of your perfect cubes list whenever you're reducing the numbers. But we'll multiply those together to get 270. And we'll add our exponents to get x to the 7th and y to the 5th. So I'm thinking 270, 27, and 10 would be my two numbers. And then we will break this into the cube root of x to the 6th times the cube root of x to the 1st. 6 plus 1 gets me back to 7. And then I will break my y's into cube root of y to the 3rd and y to the 2nd. And we can simplify that down a little bit and we'll be done. So this will be 3. The cube root of x to the 6th is x squared. And the cube root of y cubed is just y. So those are my outside terms, and then everything else goes back under one cube root. Oops, I lost my x. Now, some students don't like having to write out all these roots separately, so if you want, you can just do this and write all of them under one. Just be careful that you do take out what's supposed to be on the outside and what's supposed to be left on the inside. So you guys can try the foreclosure problems. And then this homework is wrong. I did actually change that. It is on my Google Classroom now.